Who needs IPv6? Let's answer that question with another question. Do you use the commodity internet? If the answer is yes, then you probably need IPv6. What is IPv6? Well, IP in general. Every internet-enabled device is addressed with something that makes it unique on the internet. So it's reachable from services that are web-enabled or makes web-enabled services reachable to your PC or handheld device. There are two versions of IP that are de facto on the internet today, IP version 4 and IP version 6. What's the difference between the two? Well, we're going to cover that here. But basically, IP version 4 is being phased out because they had never planned on it to be the de facto standard. When I say they, I mean the framers of the internet. IPv6 is going to solve all the problems posed by IPv4. Some of those problems really have to relate with the size of the address space that's allowed. So unlike your house or your business, which has an address that's geographically bound, right, leaving it pretty much endless, the possibilities of what addresses can go on a structure are pretty much endless depending on where you put that structure. With internet-enabled devices, your limitation has to do with the amount of bits, the ones and zeros, that are allocated to the address of the device. In IP version 4, we had 32 bits allocated to addressing devices. This left us with 4.3 billion addresses to give out to the internet. If you take a look at that number and you know the latest census data, I don't think there's a global census, but there's approximately 7 billion people in the world, so there's not even enough addresses for every human on the planet. And I'm going to use myself as an example. I have 2 PCs, 2 iPhones, 2 iPads, and a slew of other IP-enabled devices. I'm not bragging, I just have a lot of people who live in my house. So if I'm taking up 10 IP addresses myself, and I consider myself average to all other internet users, then 4.3 billion is not going to be enough, especially for developing countries that are now internet enabled. They're high speed enabled, not only to the PCs that are in their work environment or in their schools or in their homes, but now to their mobile handhelds. IPv6 solves that size problem by offering 128 bits to the address space. This means that everybody can have a /96. With 128-bit address space, a /96 means that everybody on the planet can have an address space the size of the old IPv4 address. So use your 4.3 billion addresses wisely. And when we talk about who's using these addresses, think about anything that can be IP enabled. There's the obvious things like our tablets, our e-readers, our PCs, our mobile devices. And then we have the things that are developing into the IP realm that are becoming internet enabled, our appliances, our vehicles, the flagpole, the mailbox, anything that provides a service to you that you can get information from will end up being IP enabled, or IPv6 allows that to happen because the address space is much larger now. So how do we go from our IPv4 world to the IPv6 world? Is that difficult? Well, IPv6 has been around since the mid-90s. Like I said before, the framers of the internet knew that IPv4 wasn't really going to be the long-term solution. So they quickly made the IPv6 standard. The problem is IPv4 worked for everybody who was using the internet. And then we masked the problems of the saturation of IP addresses over the internet by creating standards like RFC 1918 and started NATing our internal networks to outside addresses, thereby saving or conserving the IPv4 address space. But we are getting to the point now where there are no addresses left in IPv4 address space. We have to go to IPv6. Nobody's going to really be motivated to do that until the fear of the scarcity becomes a reality. So until Aaron here in North America says we have no more IPv4 addresses to give, it isn't going to be until that point that everybody's going to actually be motivated to move. And what's going to motivate them there is that any new businesses that request IP addresses from Aaron after all IPv4 addresses are gone will be IPv6 only. And something I didn't mention before, but IPv6 is not really backwards compatible to IPv4. All of us very smart internet engineers didn't create a next generation protocol that was backwards compatible. So there are two separate internets, our version 6 and our version 4. Now, the best way to migrate to that, and what everybody is recommending right now, is to run what's called dual stack. Dual stack means you connect your router that faces the internet to both the IPv4 and the IPv6 internet. Why can't we exist on like that from here on out? Well, it's eating up resources and costing you money in the meantime. So every time you send something v4 or v6, you're basically bridging the two internets together so that you can have all resources available, which is how we're going to live for the near term future. When I say near term, probably the next 20 years is how long we're going to be living like that. I was talking to a customer recently who, this wasn't an IPv6 engagement, but listening to how they have their IPv4 network configured, it's going to be a nightmare for them to actually integrate IPv6, and it's going to take so long. So everybody's going to be running in this dual stack mode. It's not ideal because, again, we're doubling the processing. We're processing version 4 addresses, and we're also processing version 6 addresses. Every device has to be able to process both of those. Two different protocols. They are completely separate protocols. So migration really is an effort of, first of all, getting yourself onto the IPv6 internet and then identifying what needs do I have when it comes to internet enabled devices, and do all of my existing applications that work successfully on IPv4 work properly on IPv6. And while you're running dual stack, you can answer all of those questions. Finally, what are some of the benefits of IPv6? What's going to motivate people to move from IP version 4 to IP version 6? Like I said earlier, it's going to be the scarcity that is the main motivator, right? Once a business is no longer able to present their web services to new clients who come up in version 6, then they're going to be motivated to change, right? If they can't reach their customer anymore, that's when organizations and individuals are going to actually be concerned about being IPv6 enabled. But for us, the technical junkies who know what's happening on the internet transport, what's really appealing about IPv6 is obviously the larger IP space, the more refined IP header. The header is smaller, processes a lot better. The integrated security features with IPsec. IPsec is required to be enabled on all IPv6 devices. This doesn't mean that every communication that you send via IPv6 is going to be encrypted, and that in order for you to communicate with anything on IPv6, you need to exchange keys. That's not what that means at all. It means that if you want the features of encryption, they are readily available because IPv6 requires them to be on every device. So that basically answers the question about what IPv6 is. Our upcoming lectures are going to talk about IPv6 addressing and how we actually apply IPv6 addresses to certain device types, whether they be Cisco routers or your MacBook Pros, Unix devices, PCs. We're going to go through all of that.